Chapter 8. So Chapter 8, it consists of sections 8.1, 8.6, and 8.7, but we don't cover everything. We kind of pull things from these sections, and I just created it as one section notes. But this is covering 3 sections of Chapter 8, but just select things from each section. So this is from 8.1, Systems of Equations. So we've known about systems of equations. That's when you have 2 equations, you put them together, you find stuff out about them. The supply and demand from chapter 4, that's a system of equations. So this is what we're used to, that when they cross, that's the solution. If they're parallel lines, they're inconsistent. If they're the same line, they're consistent and dependent. So that's what 2 variable systems looks like. 2 variable systems, we're actually talking about like x and y. So if you have x and y and you have 2 equations. All right, 3 variable systems. This is the first time ever that we're going to talk about a third variable, x, y, now z. So if you have an XYZ 3 systems, 3 variables, when you graph a 3D plane, that's what it looks like in A. You'll learn how to graph that if you're going to go to calculus and stuff like that. So that's when they all cross at a point, and that's going to be a solution set. If you graph them and they come out as a line, or they come out as the same surface, they're consistent, they're infinite solutions. If all 3 don't cross together, so only 2 cross, 2 cross, 2 cross, or they're all separate planes, it's no solution. You're going to learn more about graphing 3 equations, 3 variable systems in calculus, but today we're just going to learn how to solve them using substitution. So how we solve it traditionally using 2 system variables, it's not far off from that. Alright, there is not just one way to solve 3 variable systems. There's many ways you can think about it, but I feel like the more ways given, the harder it is to start. So I came up with a system that works. So it's okay, just bear with me. It's not going to make any sense until I explain it. Okay, so this is the system. Again, it's going to make no sense until we actually do it. So you have 1, 2, and 3 equations. 1 is just 1. So you take 1 and 2, you add it. You add it to something called new 2. You take 1 and 3 and add it. You add it to something that's called new 3. After you get your new 2 and your new 3, you add those, you solve, you plug in. It's going to make no sense until we actually do it, so just bear with me with this. Alright, so we're going to solve the system. If it's no solution, we're going to say it's no solution. We'll have a no solution. I'll show you what that looks like. So we have x minus 2y plus 3z equals 7, 2x plus y plus z equals 4, negative 3x plus 2y minus 2z equals negative 10. So the first thing that we're going to do is number our equations. So we're going to number this one 1, this one 2, and this one 3. That's where we get 1, 2, 3 from. Now we look at the variables. All 1, 2, 3, they all have xyz, xyz, xyz. So that's something that matters. I'll have an example when that doesn't happen to show you why that matters and what to do from there. So we need to find new 2. We find new 2 by adding 1 and 2. So equation 1, that's x minus 2y plus 3z equals 7. And equation 2, we have 2x plus y plus z equals 4. So our goal is to get rid of a variable. So our goal is to get rid of a variable. You can get rid of x, y, or z. It does not matter what you want to get rid of. It truly doesn't. I'm going to get rid of y. Why? I love that. Why? Because you see how this y, it's negative 2y, this one's positive y, they're already opposites. Now we need to get them to be the same number. So in order to get them to be the same number, we need to multiply the denominator by 2. So the top we did not touch, just rewrite it. X minus 2y plus 3z equals 7. Now on the bottom, we're going to distribute 2. So 2 times 2x, that's 4x. 2 times y is 2y. 2 times z is 2z. And 2 times 4 is 8. Do you notice now how our y's can cancel each other out? So when we add these, the y gets canceled out, and we're left with x plus 4x, that's 5x. 3z plus 2z, that's 5z. 7 plus 8, we get 15. This is called our new 2. So now we have new 2. Now we need to find new 3. So for new 3, you take equation 1 and equation 3. So when we found new 2, we got rid of y. That means you have to get rid of y. Whatever you do first, you have to repeat the steps for new 3. So we got rid of y in new 2. So we got rid of y in new 2. So you must get rid of y for new 3. No matter what, you have to get rid of it. You cannot change it. It has to be the same. You have to stay consistent. So if we look at y, we have negative 2y and positive 2y. They're already opposites of each other. Since they're already opposites of each other, we don't need to do anything. They already cancel each other out. Heck yeah. So we have x minus 3x, that's negative 2x. Positive 3z minus 2z, that's positive 1z. And 7 minus 10, we get negative 3. This is our new 3. So now we have new 2 and we have new 3. Now we need to add them together. So let's rewrite new 2. New 2 is 5x plus 5z equals 15. New 3 is negative 2x plus z equals negative 3. Do you notice that now we only have 2 variables? So now we just keep solving how we always solved systems of equations. So we're going to look only at these new 2 and new 3. Get rid of a variable, it doesn't matter. You can get rid of x, you can get rid of z, it truly doesn't matter. I decided to get rid of z. Why z? Because there's nothing in front of my orange z. When there's nothing in front, that's kind of like the variable you want to work with. So for our z, on our new 2, it's 5. So that means the bottom needs to be negative 5. It's always the opposite. So we need to multiply by negative 5 to make it the same number but opposite sign. So let's do that. We did nothing to the top. We're changing the bottom, so negative 5 times negative 2x is positive 10x. Negative 5 times positive z is negative 5z. And negative 5 times negative 3 is positive 15. We're going to add these together. Our z's cancel. We're left with 15x equals 30. Divide by 15. And we get x is 2. So now we need to keep solving, because now that we have x is 2, we can plug it in to either equation, either new 2 or new 3, to find z. It doesn't matter, you can plug it into any one. I'm going to plug it into the top one. So let's plug it in. We have 5x, which is 2, plus 5z equals 15. So we have 10 plus 5z equals 15. Subtract 10. We have 5z equals 5. Divide by 5. And we get z equals 1. So we have x, we have z. We're missing y, because that was the first variable we got rid of. So right now, we're here. We solved. We solved it. Now that we solved it, we need to plug in. So that means we need to plug in x and z to find y. You can plug it in to any one. 1, 2, or 3. It does not matter which one you plug it into. But remember, we need to solve for y. So we need to solve for this variable right here. If we look, this equation, there's nothing in front of y, so it's going to be easier to solve for. So I'm going to plug it into equation 2. So equation 2, that's represented by 2x plus y plus z equals 4. So let's plug it in. We have 2x, which is 2, plus y, we don't know it, that's what we're trying to find, plus z, so plus 1, and that equals 4. So we have 4 plus y plus 1 equals 4. That leaves us with 5 plus y equals 4. We subtract 5. And we get y equals -1. So our solution, it's a point. The point goes x, y, z, because now we have an extra variable. So we have 2, -1, 1. When you learn to graph this, that is where it will all meet. All right, we're going to practice that all over again with example 2. So if you're feeling like you can maybe do this without me, maybe try example 2. Maybe just try it. It's the same steps, just different numbers. All right, so the first thing we do is we number. All right, so now we need to find new 2. So let's look. We have xyz, xyz, xyz. They all have the same variable, so we just got to check, just double check in there. So to find new 2, we're going to add 1 and 2. Now again, it doesn't matter what variable you get rid of. You can get rid of any variable you like. It's truly up to you. I'm going to get rid of x just because I wanted to. You can get rid of y, you can get rid of z. It truly does not matter. So I'm going to get rid of x. So I have x and 2x. That means the top needs to be -2x. It needs to be the same number but opposite sign. So we're going to multiply by -2. So we'll have -2x positive 6y minus 8z equals -18. Now, the bottom, we didn't do anything, so just rewrite it. And we add. So our x's cancel, that was our goal. We have 6y and y, that's 7y. -8z and z is -7z. And -18 and 4, that is -14. So that's our new 2. Now we need to find new 3. So for new 3, remember, we got rid of x for new 2. That means we must get rid of x for new 3. So to find new 3, we take 1 and 3. So we must get rid of x. Since that's the case, they need to be the same number but opposite signs. So they're already opposite signs. Now we just need to be the same number. So we're going to multiply by 2. So we'll have 2x minus 6y plus 8z equals 18. On the bottom, we didn't do anything. All right, let's go ahead and add. Our x's cancel. That was the goal. Sweet, we did it. So we have -6y, positive 3y. That's -3y. Positive 8z, -3z. That's positive 5z. And 18 minus 10, we get 8. That's our new 3. Now we take our new equations and go ahead and put them together. So our new 2, we have 7y minus 7z equals -14. Our new 3, we have -3y plus 5z equals 8. It does not matter what you get rid of. It could be y, it could be z. It truly doesn't matter. I got rid of y. Why? I don't know. I just wanted to. You can get rid of z. It's totally up to you. So we need 7 and 3 to be the same number. That means you just multiply them together. They're already opposite signs, so we don't care about messing with the signs. They're already opposite. So we're going to multiply our numbers together. So we're going to multiply the top by 3 and the bottom by 7. So we'll have 21y minus 21z equals negative 14 times 3, which is negative 42. And then on the bottom, we will have negative 21y plus 35z equals 56. We're going to add these together and our y's cancel. That was the goal. So negative 21z plus 35z, we get 14z equals negative 42, 56, that's 14. We divide by 14, so z equals 1. Now we have to plug it back in to find y. It doesn't matter which one you plug it into. I plugged it into the bottom one because they're smaller numbers. Really no other reason why. So we have negative 3y plus 5z equals 8. So we have negative 3y plus 5z. We found z to be 1. And that equals 8. So we have negative 3y plus 5 equals 8. Subtract 5. We have negative 3y equals 3. Divide by negative 3. We get y equals negative 1. So we have z, we have y, all we're missing is x. And that's the first variable we got rid of. So whatever variable you get rid of for nu2 and nu3, that's the last variable you're going to find. So it does not matter. We can plug it into 1, we can plug it into 2, we can plug it into 3. I plugged it into 1 because we need to find x and there's nothing in front of x. So we're going to plug it into 1. So equation 1, that's x minus 3y plus 4z equals 9. Alright, we need to find x. We don't have it. We found y. When we found y, it was negative 1. Then we're going to add that to 4z. We found z. When we found z, it equaled positive 1. So we have x plus 3 plus 4 equals 9. So we have x plus 7 equals 9. That means we get x equals 2. So when we write our answer, it goes x, y, z because it's a point. So we have x is 2, y is negative 1, and z was 1. Alright, example 3. We have x minus y minus z equals 3, 5x plus 5y plus z equals 3, and 24x plus 16y equals 0. Alright, let's number. 1, 2, 3. We need to find nu2. But before we do that, don't forget, XYZ, XYZ, XY, no Z. No Z. Oh my gosh, we're missing Z. We're missing a Z in one of the equations, so don't touch Z in any equation. If you're missing a variable, don't touch it. Don't touch that variable. Leave it alone in every single equation. Don't worry, it'll all work out some way. Alright, so we need to find nu2. We still don't change the process. We still add 1 and 2. So we have x minus y minus z equals 3. And then we have 5x plus 5y plus z equals 3. It's tempting to get rid of that z, right? Because they're already in the opposites of each other. However, equation 3 doesn't have a z, so you can't touch it. Leave it alone. So you can touch x or y. You can get rid of x or you can get rid of y. It doesn't matter. I'm looking at y Why? Because they're already opposites of each other. That one's always negative, that one's already positive. So that means we just need to multiply by 5 to get them to be the same value, the same number. So we'll have 5x minus 5z minus, 5y minus 5z equals 15. And then we didn't touch the bottom, we didn't mess with it, so we just keep it the same. And then we add. So our y's get rid of each other. We have 10x minus 4z equals 18. And there's our new 2. Now we need to find new 3. Alright, for new 2, we got rid of y. That means in new 3, we must get rid of y. So we have x minus y minus z equals 3. And 24x plus 16y equals 0. Alright, we gotta get rid of y. That is the must, so luckily they're already opposite signs. We just need to be the same number, so we're gonna multiply the top by 16. And when we do, we'll have 16x minus 16y minus 16z equals 48. And on the bottom, we have 24x plus 16y equals 0. Our y's cancel, that was the goal, sweet. We got 16 and 24x, that's 40x. Nothing there, so we just minus 16z equals 48, and that's our new 3. You see how for new 2 we have xz, for new 3 we have xz? That's why we can't touch z, because at the end of it, we need to have the variables match. Now we're going to add these together. So our new 2, we have 10x minus 4z equals 18. Our new 3, we have 40x minus 16z equals 48. Now it's up to you what you want to get rid of. It truly does not matter. I'll tell you though, I got rid of z. Why? No, I mean literally no reason. I just wanted to get rid of z. So I need them to be the same number and opposite sides. So for them to be the same number, I need to multiply by 4. In order for them to be opposite sides, I need to multiply by negative 4. So we have negative 40x plus 16z equals negative 72. On the bottom, we have 40x minus 16z equals 48. Alright, we cancel out the z's. That was the goal. We have negative 40 and 40, that goes away. We have nothing left. When you have nothing, it's 0. So we have 0 equals negative 24. That's not true. 0 does not equal 24. This is a no solution. However, how we say no solution now, we say inconsistent. This does not happen every time when you're missing a variable at the beginning. That's not why it's inconsistent. It just so happens that there's no solution, meaning they actually never all cross together. If you got a true statement like 0 equals 0, negative 24 equals negative 24, that would be consistent. That would be infinite solutions. So if you have a not true statement, like we do above, it's inconsistent. If you do have a true statement, it's going to be consistent. Meaning a true statement is you have the same number equals the same number. Alright, moving on to stuff in 8.6, systems of nonlinear equations. So we're still messing with systems, we're still solving systems, but this time we're only messing with 2 variables instead of 3. So up until now, you've solved systems of equations and they were linear. It was like x plus y equals whatever. So now we're going to see how we solve them if they're not linear. So we have xy equals 6, 6x squared plus y squared equals 42. I will tell you, we have to use substitution. Why? Because none of our variables match. That's x squared, y squared, that's xy. They're completely different, so we need to use substitution. So to use substitution, we need to solve for any variable in any equation and then plug it into the other one. If you have squares, don't touch that equation ever. Don't touch it. What we're going to work with is this equation right here. The reason being is because there's no squares. So we have xy equals 6. Solve for any variable. Any variable. I'm going to solve for y. Why? Because if I look, that's just y squared. I know I'm eventually going to plug it into y squared, so that's why I'm going to solve for y. So we divide by x, and we get y equals 6 over x. So whatever y is, it's represented by 6 over x. So we're going to plug this in because that's what y is. So we have 6x squared plus y squared equals 42, and y squared is 6 over x. All right, let's simplify. We have to square. So we have 6x squared plus 36 over x squared equals 42. We have to get rid of our fraction. In order to get rid of our fraction, you always multiply by the denominator. So we're going to multiply everything by x squared. So x squared times 6x squared, that's 6x to the 4th. X squared times 36, that's 36 over x squared, that's just 36 because we're getting rid of that denominator. And then 42 times x squared, that's 42x squared. We have a trinomial, so we're going to equal this to 0. We can factor this because it's 4, 2, nothing. When it's 4, 2, nothing, you're allowed to factor. However, before we factor, they have a common term. They all have 6 in common. So take it out. And don't forget, you have to take out the common term if you're factoring. So we can factor this because that's x to the 4th. That's x squared. X squared. The plus tells us same signs. Minus tells us it's going to be minus minus. Now we need two numbers that multiply to 6 that add to 7. That's 6 and 1. Now we have factors, so let's set each factor equal to 0. We have 6 equals 0. That doesn't make sense because it is nothing. We have x squared minus 6 equals 0, and we have x squared minus 1 equals 0. So we have x squared equals 6. We square root it. And we get x equals positive negative square root of 6. Same thing on the right side. We're going to add 1, so we have x squared equals 1. We square root it. So we get x equals positive negative 1. So now we have our x's, we need to find y. So now we need to plug it in to find y. Because we have a square root, you want to plug it into something that's squared. So we have two x's for our negative 6, or for our square root of 6, and then we have two 1s. So let's plug it in. We're going to plug it into 6x squared plus y squared equals 42. And the reason why is because there's a square root, so we know the square is going to get rid of the square root. So we have 6 times the square root of 6, and we're squaring that, plus y squared equals 42. The square gets rid of itself, so we have 6 times 6, that's 36, plus y squared equals 42. Subtract 36, we have y squared equals 6, we square root, and we get y equals positive negative square root of 6. Since we're squaring the x, no matter what, it's going to come out positive. No matter what, we're still going to get the same answer because it's squared. So since we know it's squared, we don't have to plug it in. We can just say we know the answer is going to be y equals positive negative square root of 6. That trick only works when they're the same radical and you're squaring. Because remember, positive squared, negative squared, it all comes out positive. So that's why we really don't care. Now, if you want to, you can plug it in and just prove to yourself that you get the same answer at the end of the day. So that was for our x square root of 6. Don't forget, we also have positive negative 1. This is a lot of work. You are not wrong by thinking that. So let's plug in our positive and negative 1. I'm going to do it below right here. So we have x equals negative 1 and x equals 1. It doesn't matter which one you plug it into. Now, since there's no square roots or nothing fancy, let's just plug it into xy equals 6. So we're going to plug it into xy equals 6. So we have xy equals 6. X is negative 1, so we have negative 1y equals 6. We divide by negative 1, so we get y equals negative 6. I would do the same thing with 1. So we have xy equals 6. So we have 1y equals 6. That means y equals 6. So our final answer, this is how we're going to write it out. Already, example 2, we have y equals 2x plus 3, 4x squared plus y squared equals 9. Remember, don't touch squares, ever. Don't touch squares. You want to leave them alone. We also have to use substitution because we have yx, x squared, y squared. They don't match. You need things to match and you never want to start multiplying by x and y. So we need to use substitution. That means one variable needs to be solved for and you need to plug it in. We already have something solved for. We have y equals whatever. So we're going to plug this in as y because that's what y represents. So we have 4x squared plus blank squared equals 9. And in that blank, we have 2x plus 3. Alright, that means we need to square 2x plus 3. So don't forget that you need to square it. So when we square it, we have 4x squared. That doesn't change. But when we square 2x plus 3, we get 4x squared plus 12x plus 9. And that equals 9. Let's combine like terms. We have 8x squared plus 12x plus 9 equals 9. Let's equal this to 0 because it's a quadratic and a trinomial, so we subtract 9 over. We get 8x squared plus 12x equals 0. Our 9's cancel. When it's a binomial, there's only one way to solve this, and that's greatest common factor. They have 4x in common. So 4x out of 8x squared, we're left to 2x. 4x out of 12x, we're just left with 3. We have 4x equals 0. 2x plus 3 equals 0. So we have x equals 0. We subtract 3, so 2x equals negative 3. Divide by 2, we get negative 3 over 2. So we have two x's. We have x equals 0 and x equals negative 3 over 2. It doesn't matter which one you plug it into, but I'll tell you, something is a lot easier to plug it into, and it's the top one. The reason why? Because it's not squared. It's just a linear equation, much easier to approach. So we're going to plug both of these into y equals 2x plus 3. So we have y equals 2x, which is 0, plus 3. So we have y equals 3. So that's 0, 3. Alright, then we'll have y equals 2 times negative 3 over 2, all plus 3. Our 2's cancel out, so we have negative 3 plus 3, and that's 0. So that's negative 3 over 2, 0. You can graph both of these because you actually know how to graph a line and you know how to graph a quadra or a circle. If you graph them, that's exactly where they would meet. Alrighty. Example 3, we have x squared minus 3y minus 13 equals 0, and then we have 2x squared plus y squared equals 4. So we want things to match up. We have this random negative 13 here. We don't want it there. We want things to look the same and nice and neat. So let's just move it over. We have x squared minus 3y squared equals positive 13, and then we have 2x squared plus y squared equals 54. Now, if we look to see what we have x squared, y squared, x squared, y squared. Since that's the case, you can use elimination to solve this. Just like we were doing up here with our lines, we can actually do the same process because they match. Only when our variables match, like square, square, we can actually use elimination. So you can get rid of anything. I'm going to get rid of y. Why? Because the one's negative, one's positive. So what's missing, we just need this one to be a 3. So we're going to multiply by 3. We have x squared minus 3y squared equals 13. And then we have 6x squared plus 3y squared equals 162. Our y's cancel. We're left with 7x squared equals 175. Divide by 7, so we have x squared equals 25. We square root it. That means we have x equals positive negative 5. So we have two answers. We have x equals negative 5 and x equals 5. Now we're going to figure out which one do we want to plug it into. It doesn't matter. You can plug it into the top, you can plug it into the bottom, you can even plug it in to this one right here. It does not matter. Now we need to solve for y, so I'm actually going to plug it in to this one. Why? Because there's nothing in front of y squared. Because y squared is just y squared. So I'm going to plug it into 2x squared plus y squared equals 54. However, it doesn't matter. You decide. You get to choose your destiny with this. Let's plug it in. We have 2 blank plus y squared equals 54. And in that blank, we're plugging in negative 5. So we have 2 times negative 5 squared, that's 25, plus y squared equals 54. We have 50 plus y squared equals 54. We subtract 50, so we have y squared equals 4. We square root, and we get y equals positive negative 2. So that means we have negative 5 positive 2 and negative 5 negative 2. All right, now we need to do 5. So we have 2 times 5 squared plus y squared equals 54. However, do you notice that it's being squared? If it's being squared, you know you're going to get the same answer because it's squared. When you're squaring it, you're going to get the same answer at the end of the day. You can work it out if you want to. You're still going to get positive negative 2. So that means we'll have 5 negative 2 and 5 positive 2.